Okay, in this video, we're going to first talk about monopolies, what they are, and how they maximize profit. So we'll talk about the monopolies' profit maximization process, how they solve their firm's problem. Then we're going to talk about market power. So we're going to relate marginal revenue to an elasticity of demand. And we'll talk about how this elasticity of demand sort of embeds a few different market types in this relationship, and particularly perfect competition. So we'll talk a little bit about perfect competition when we talk about market power. We'll talk about taxes in the context of monopoly. We won't do any real problems here, but we'll talk about some of the results with taxes on monopolists. We'll save some of this for a later demo video coming out tomorrow. We will talk about other types of government regulations for dealing with market power. So one of the main ones will be a price control, and we'll walk through how these alternative forms of government regulation in the context of market power impact welfare. And then finally, we're going to close out by talking about monopsony, which is when we have one buyer and many sellers. And we'll look at a case of a company town with a minimum wage. Okay. So first we'll start off with our standard firm's problem, but for the monopolist, where sort of as we typically do, we treat firms as profit maximizers. And just, as the standard caveat here, the assumption that firms are profit maximizers makes our lives a lot simpler when we deal with the firm's problem, but also less realistic. There may be other motivations for firms to make their choices. Some of them may be altruistic, some of them may be egotistic. There's a lot of speculation around tall skyscrapers being mostly egotistic, or at least largely egotistic. So what we're going to do is sort of abstract away from a lot of those problems. We're going to make the model as simple as we can. It's already work to get through it. So we're gonna make some simplifying assumptions to make our life easier, while realizing that they are simplifying assumptions and don't necessarily match the real world perfectly. Okay, so for the monopolist, they're facing a profit function, just like all other firms. This profit function depends on the shape of the demand curve for the goods they're selling. And given this demand curve, they're going to choose their price and quantity. And it's important to note here that this process is identical for all types of firms, no matter what the environment is. So you've seen these three steps already in the context of perfect competition. They're the exact same steps. There are some differences in the environment that the firms are making their choices in, but their choices, the way they make them, is identical. And the big difference between the monopolist and the perfectly competitive firm is the demand curve. For the perfectly competitive firm, the demand curve is perfectly flat. In the perfect competition world, the demand curve is flat. So firms have no ability to change the price by changing quantity. In the monopoly, in the monopolist's world, the demand curve is downward sloping. So changing the quantity does change the price that they'll charge. So this makes the model a little bit more complicated than the perfectly competitive firm. And so we have to sort of we have to match our model to this reality. Okay, so to do this, to solve the firm's problem, we first choose quantity. And this is where the marginal cost intersects the marginal revenue curve. This is the profit maximizing quantity. Then, once we've found the profit maximizing quantity, we run it up to the demand curve, plug it into the demand curve, and that tells us the price. So we just plug in the quantity we found, and that gives us the price. And then last but not least, we check whether the monopolist is making a profit, an economic profit, at that quantity and price. And the big difference between perfectly competitive firms and monopolists when it comes to their shutdown condition is that because monopolists are the only firms operating in the market and are the only firms ever that will operate in the market for the good they're selling, by definition of being a monopolist, there is no entry. So they don't really have to face entry or exit from the market for other firms. So because of this, we don't typically deal with differences in short run and long run. We typically model the monopolist as just a long run firm. And this makes our shutdown decision much easier. We just want to make sure that we are at least breaking even. So you could include an equal sign here if you like, a weekly grader. And this is actually backwards here. We want this to be price greater than or equal to average cost. Okay. Okay, so I wrote in my notes here that I just want to reinforce the point here that these three steps are identical to the perfectly competitive firm. The only difference is that the demand curve looks different and there's no entry and exit, so the shutdown decision is much simpler. So we've made the demand curve more complicated, but the shutdown decision simpler. Okay. So because we have a downward sloping demand curve, the marginal revenue curve is also downward sloping. Where before the marginal revenue curve was just the price, a flat line, which was also the demand curve. Here we actually have to sort of do a little bit of extra work to find marginal revenue. So to find the slope of the revenue curve, the marginal revenue, we take revenue and we differentiate it with respect to Q. Because revenue is just price times quantity, and price depends on quantity, when we take the derivative of this relationship, we have to use the product rule, and we end up with the derivative of the price with respect to quantity times quantity plus 1 times the price. Then doing a little bit of trickery here, we bring price out and rearrange the inside. So we have 1 times P plus this whole thing divided by p, and then we multiply by p again on the outside. So it's all the same. We just have p on the outside, and this interior, this first component of the interior, is just the elasticity of demand, 1 over the elasticity of demand, which gives us this final relationship here, which relates, so this relationship here, which relates the elasticity of demand to the marginal revenue curve. So when we think back to the demand curve for perfectly competitive firms, where we had price, quantity, our demand curve was perfectly horizontal, so we had demand like this. And our elasticity measure is the percent change in quantity over the percent change in price. So let's imagine we change quantity, we increase quantity. So we're going up, so our top part is positive. Price, because the demand curve is perfectly flat, or close to perfectly flat, is very, very small. So this bottom piece here is very small. Essentially 0. When the bottom is close to 0 and the top is some positive number, this is close to infinity. So we have something close to an infinite elasticity of demand in the perfectly competitive market. So what this means for the marginal revenue in the perfectly competitive market is that it's just the price. So when we plug in infinity into the bottom, this whole thing goes to 0. This goes to 0. And all we're left with is P, which is our marginal revenue curve in the perfectly competitive market. But here, because there is some slope to the marginal revenue curve, to the demand curve, the elasticity of demand is not 0, or is not infinity. So we get some difference between price and marginal revenue. And this difference is how we define market power. And we'll get to this in just a second. Okay, so this is cool. We've related marginal revenue to elasticity of demand, and we have embedded other types of market structures in this relationship here, this entire relationship here, through elasticity of demand. So all we're looking at is one example of this relationship when there is market power. Okay. So let's walk through a little example here, just with the simplest of demand curves. We just have a linear demand curve. So we have our intercept, an intercept A, and then we have a downward sloping demand curve. We have Q and P. We have a cost curve. So we have cost on the vertical axis. We have our fixed cost F, which with Q squared increases. And we have our marginal cost, which looks something more like this. It's linear, so it's increasing linearly with Q. It might be a little steeper than that, but it's linear. And then our marginal revenue curve is just the derivative of revenue, which is price coming from the demand curve as a function of Q times Q. Then we take the derivative of this. And when I take derivatives of quadratics like this, I like to expand them. So when I do that, I end up with A minus 2Q. Okay, so then this looks something along these lines. Marginal revenue, we have an intercept of A, and then decreasing pretty steeply in Q. Okay, so that's kind of the setup. To solve the monopolist problem, the first thing we do, right, is we set MR equal to MC. And we'll do all this graphically in just a second. I just want to set this up mathematically. It's, yeah, a little off-brand, I know, to do the math first and then set up the graph. But you'll see why in just a second. So we have our MR equal MC condition. We plug in our MR, which we just solved for here, and then our MC, which we solved for just up above, the derivative of the cost curve. And then when we solve for them, when we solve for Q, we get A over 4. All right. So we've found the monopolist's quantity decision. All we have to do next is plug in this quantity into the demand curve. And that's going to give us our price, our optimal price. So we just essentially ran the quantity up until it hit the demand curve, selling at the highest price we can sell everything. So all we're doing is just plugging in for Q. So this is a typo here. Let's get rid of that. Okay, so when we do this, the price comes out to be 3 or 4A. Okay, so we found the price, we found the quantity. We're not going to check the profit mathematically, but we will do it graphically. So this is the general setup, right, to the monopolist's market structure. And this is how we solve the monopolist's problem. And it looks like I made a little boo-boo here, so let's fix this. We have revenue minus costs. So let's just walk through the monopolist problem graphically, and then we'll talk about where it's coming from. So first, we set we want to find the point on the profit function that is highest, which happens here. When we differentiate the profit function, we get our marginal profit, which is equal to marginal revenue minus marginal cost. This equals 0 at the maximum. And so when we set these equal to each other, we also arrive at the maximum, the quantity that maximizes profit. So to do this on the top graph, our marginal and average graph, all we do is intersect the marginal with the marginal cost with marginal revenue. That gives us our quantity. We plug that into the demand curve. We run it all the way up to the demand curve to find our price. Once we do that, we can find our profit using this equation here by finding the price, the quantity, and then lastly, the average cost. So we intersect the quantity with our average cost curve to give us average cost. And that tells us the profit, which is the area inside this rectangle. Okay. So that's the firm's problem in both mathematical and graphical forms. So a couple points here. First, we've already walked through why profit is maximized when MR is equal to MC. All we're doing is, this is the equivalent of a first order condition. We're taking profit and we're setting the derivative equal to 0. So we're finding where the 0 line, the line with a flat slope, is tangent to profit. And that's where the maximum happens. And we're charging as high a price as possible, which comes from the demand curve. And then we found the area, which is, in this graph, is the brown shaded region. This thing here. Okay. So that's what we're doing with the firm's problem. Now that we have the tool set to evaluate the firm's problem, let's walk through some market power and government policies. Oh, excuse me, welfare. We're going to get to government policies in just a second. Okay. So because the firm, the monopolist, has the ability to charge a price that's above its marginal cost, this is what we call market power. The ability to charge a price above marginal cost. This market power comes from the shape of the demand curve, and specifically the responsiveness of the demand curve. When there's a flat demand curve, there's no real difference between the marginal revenue and the marginal the marginal benefit, or the willingness to pay line. But with a very steep demand curve, there is a difference. So the marginal revenue is much lower than the marginal cost. Excuse me, than the marginal benefit line. And this shape is partly coming from the market structure, the availability of substitutes. But there's also necessity playing a role here. So things like if you have a monopoly on groceries, on food, then you would have quite a bit of market power just because people need to buy it no matter what the price is. Okay. And the elasticity here, as we derived above, is what determines market power. Okay. So when we think about market power, it's related to the shape, the slope, and specifically the elasticity of the demand curve. When the demand curve is less elastic, we have greater market power, and we have a greater deadweight loss. So we can look at welfare in this context by walking through the solution to the monopolist problem. We intersect marginal revenue and marginal cost to find our quantity. We run that quantity up until it hits the demand curve, which gives us our price. We have our marginal cost and our price. So we have this purple line here, which is the markup, the price above the marginal cost. So that's the markup, which means the monopolist is able to capture some of the consumer's original surplus, if we were in a perfectly competitive market. So this area here is what would have been consumer surplus that is now producer surplus. And because the firm is able to increase their prices by decreasing their quantity, the firm is also decreasing quantity relative to our sort of benchmark, our perfectly competitive market. Okay, so we've lowered quantity and increased prices. We've marked up our prices relative to marginal cost. And both of these factors give us a deadweight loss. So we have a deadweight loss in this market, which isn't ideal. And we've transferred some consumer surplus to producer surplus. Okay. So this is somewhat undesirable, right? We don't like either of these factors. Which makes monopolies pretty prone to government regulation. Because we have an undesirable result in the market, governments are more likely to regulate them. So when we turn to government regulation, often the first avenue is to look at taxes. So there are two types of taxes we tend to deal with. So far in this class, we've only looked at specific taxes, where we wedge price for the buyer with the price from the price for the seller with our tax tau. We're essentially putting a tax on each item that's sold. So not a tax that doesn't depend on the price. It's just putting a difference between the two prices. An ad valorem tax is a little different, where, and this is the one that we tend to see more of in our daily lives. This is the one that's, so like a sales tax of like 6%, let's say. It's a percentage of the price, not a per unit tax. So if you have something that's sold for $1 and something that's sold for $2, even if they're the same good, just sold at different places, the taxes are different between the two. One is, if you have a 6% tax, one is 6 cents, and the other is 12 cents. That's what we call an ad valorem tax. And the way we model this is along these lines. So we're separating the price for the buyer and the price for the seller, but the separation depends on the actual the actual prices. Another way of writing this is to divide both sides by PS. So we have PB over PS, which is equal to 1 plus alpha. So when alpha is 0, the price ratio is 1. But when alpha is greater than 0, the price ratio is greater than 1, which means that we've increased the price for the buyer is more than 100% of the price for the seller. So that's what this alpha is doing, is it's sort of so as the price for the seller increases, the price for the buyer is going up by a larger amount. Okay. So that's what the ad valorem tax is doing. And we're going to get to these in a later demo video. We're actually going to go through and calculate the welfare effects using these two taxes. But the main point here is that taxes actually are, in some sense, counterproductive. They're increasing the price buyers are paying and hurting both the monopolist and the consumers in the market. There's some transfer of welfare to the government, but this is coming at the expense of higher prices and a greater deadweight loss. But it's not all bad news. There's a type of policy, which you've seen before, price regulations, that do reduce market power. And they reduce market power primarily because a price regulation changes the firm's marginal revenue curve from being downward sloping to being horizontal for some region. Okay, so let's set this up. Let's say we have a price regulation, P upper bar, which lives somewhere between the monopolist's price, the price that they optimally charge, and the marginal cost. So somewhere between the marginal cost and their marked up price. We'll pick a particular point, this P upper bar, just as an example. It could live anywhere in between, so anywhere on this interval here. We're just picking one of them to demonstrate. Okay. So with this this price ceiling, the monopolist isn't changing their price based on the demand curve because they can't. So before, when we thought about the marginal revenue curve, we thought about it coming from the derivative of revenue, right? So we had revenue was equal to price, which came from the demand curve, times quantity, which came from the intersection of MR and MC. But here, the marginal revenue curve is simply, or I should say the revenue is simply P bar times quantity. So marginal revenue is just P bar. So what that means is the marginal revenue curve is just this horizontal pink line, which takes away the market power that the firm was exerting over the market, because the slope of the marginal revenue curve is now flat. Okay, so what this means is for the firm, all they're doing is choosing their quantity, QS, where the P upper bar intersects the marginal cost curve. Because we have this price ceiling, consumers, the buyers, are also using this price, which means we have a shortage, so our quantity demanded is greater than our quantity supplied, at least at this very particular point. But this is way better, because what we're seeing is quantity has gone up. The quantity's gone up from Q star to QS. Price has also gone up from gone down from P star to P upper bar. So both of these things are positive. And we've transferred this green area from from producers to consumers. And at the same time, we've transferred this gray shaded region from deadweight loss back to surplus, because we've increased our quantity from a point that was too low to a point that's still a little low, but much better than it was before. Okay, so we've increased welfare by decreasing deadweight loss, and we've transferred some surplus to consumers. Generally, we view these two effects as positive. And we've done this by changing the marginal revenue curve for the monopolist by imposing a price ceiling. if we were to perfectly target the equilibrium, the perfectly competitive sort of our benchmark equilibrium price, we would have no shortage, and we would perfectly capture surplus in the market. This is pretty difficult to do. We have some ways of getting close to it, and what you can see is that we don't even have to hit it perfectly to do better than the monopolist unregulated. All we have to do is get closer to it than we were before. Okay, so this is one way of dealing with monopolies. What we're going to do next is look at a natural monopoly. A natural monopoly is just defined as a single firm which is more efficient than many smaller firms. So the costs for the single firm are lower than if you had N firms producing the same quantity. So in natural monopolies, we get this downward sloping average cost curve. So average cost is going down as we increase quantity. So some examples of this are like Comcast, the much hated company, has a natural monopoly in a lot of areas of the country. Because adding one more internet customer to their network is very cheap for them. All they have to do is run a line from the street to the house, and in a lot of cases they don't even have to do that. They just have to switch on an existing line that's running from the street to the house. If you and I were to set up an internet company on our own, it would be very costly for us to do it. We'd have to run lines down the street, which isn't cheap. But for Comcast, they already have the infrastructure in place, so adding one more customer isn't that costly for them. So that's an example of a natural monopoly. We get a lot of natural monopolies in infrastructure type markets, so electricity, natural gas. So what do we do when we encounter these? Breaking them up probably isn't the right option, because that actually increases the costs of producing. So one thing we can do, similar to our last example, one government regulation, is some form of price regulation. So if the firm is operating without any regulation, we find where marginal cost intersects marginal revenue to find our quantity. We run that quantity up till it hits the demand curve to give us price. We find where quantity intersects the average cost curve, which gives us AC, and that gives us our profit. We also have a relatively large deadweight loss, which is this area here. That whole gray area. And we get this transfer from consumers to producers, which is equal to this area here. None of these things are good. Profit is okay, but deadweight loss and transfer from consumers to producers is generally not seen as good. So what do we do? A price regulation here is a very good option. It's not perfect, but it's pretty good. So what we can do is try to target the firm making zero profits. And we can do this when price is equal, when price is equal to average cost. So when we set price equal to average cost, profit is 0. So let's try to target that. So let's say we require price to equal average cost. So when price equals average cost, the quantity demanded happens at this point. So here's our QD. And this is, in some sense, incentive compatible. When price is equal to average cost and we have a downward sloping demand curve, monopolists don't want to increase their price. They want to increase the reach of their operation. And so they tend to at least have a slight incentive to increase. And more weakly, we can say they have no disincentive to increase their costs. But what this does is it moves quantity from Q star all the way out to QD. And it still leaves us with a little bit of deadweight loss, which is above the interval between where MC equals the demand curve and QD. So this area here is our deadweight loss. But the deadweight loss is much smaller. We've eliminated this whole trapezoid from deadweight loss. The ideal would be if we could set price equal to marginal cost. But the problem there is this would then lead us to a negative profit and the firm would shut down. So we don't want to do that. We would have a quantity of 0. So the next best is to set price equal to average cost. Okay. So the last thing on the to-do list here is to extend this notion of price regulation when we have market power into the world of monopsony. So monopsony is when we have a single buyer with many sellers. Often this looks like a company town. When you have one employer in a market, they are the buyer of labor, and you have many sellers of labor, workers. This is sort of a stark version of a relatively common market structure, what we call oligopsony, which is when you have a few buyers of labor and quite a few sellers of labor. So what we're going to walk through here is an example of a minimum wage in this environment, and we're going to show what happens to employment and to prices, as well as welfare. And this is a more stark example than what you would see in most labor markets, but some of the same principles apply relatively broadly. And what's interesting is you may have seen a model of minimum wage, right, where we have our supply and our demand. We have supply and demand, quantity on the horizontal, price on the vertical, and our sort of our market wage. Quantity here is labor, and our price is wages. And when you impose a minimum wage, what you do is create a surplus, and this is unemployment. So this is one model that's used for modeling minimum wage, but empirically, we actually don't see this result playing out. You can take a look at the literature. The jury is still a little bit out on this, but we don't see massive unemployment when the minimum wage goes up. And so one of the puzzles has been one of the goals of the empirical research has been to separate, to sort of test whether the model you've seen before, this one here, is the right one, or whether the one we're going to lay out in the next few minutes is the correct one. And because we haven't seen any shortage, or we haven't seen massive declines in employment, at least in the literature, the empirical literature, that's led some people to believe that the model I'm presenting to you right now is actually the better one. So the first thing we need to do is set up the monopsonist's expenditure. So the monopsonist is paying W, which is the wage, for every worker that's hired. So this is the expenditure on employment. To find the marginal expenditure, all we do is take the first derivative of this expenditure function here, take the first derivative, and with the product rule we get these two pieces. So first we have the wage, and second we have the derivative of the wage with respect to the to L. So how does wage change when we add L? And then we multiply that by the number of workers. And so from the law of supply, right, we have supply going up, wage and L, because wage is going up when we increase L. This thing here is positive, which means when we look at average expenditure, which is just expenditure, which is W times L over L, that's just wage. We know, so we have wage on both sides, and this thing is positive. So it must be that the marginal expenditure is greater than the average expenditure. So we have enough information to plot this. The supply curve here is just the wage function. So as wage goes up, the number of workers willing to work at that wage also goes up. But we know that the marginal expenditure is above this. So the monopsonist chooses their labor quantity at the point where their marginal expenditure is equal to the average added revenue from adding one more worker, which is what we call the marginal rate of productivity of labor, which is just the demand curve for labor. Okay, so we intersect these two. We find the labor, the firm's optimal labor choice. And similar to the monopolist, the monopsonist just takes this L star, plugs it into the supply curve to get the wage rate in the market, W star. And this is market power, so the difference between the marginal expenditure and the wage rate, but on the opposite side of the market for the monopsonist. Okay, so you can see optimally we would end up here, which is maybe, I'll call this socially efficient. And we have this socially efficient wage. And we're not at either one of them, which gives us this deadweight loss. So the idea here is somewhat similar to what we saw with the monopolist. What we're going to do is impose a minimum wage, which changes the marginal expenditure line to be flat. which eliminates the monopsonists' market power. Okay. So the idea here with the minimum wage is that it's binding whenever quantities are such that the supply curve is below this the minimum wage. So whenever we're below this point here, the minimum wage is above the supply curve, which means the minimum wage is binding. So we get this flat line for the marginal expenditure. But for quantities of labor above this point, the market actually arrives at a wage rate that's higher than the minimum wage. And so we end up back at the marginal expenditure line that we were before the price regulation. Okay. So, like before, we find the point where marginal expenditure intersects the demand curve to give us our optimal quantity, which you'll notice is already much higher than pre-regulation, this L hat. And what we've done here is increase our employment level. We've also increased the wage rate. So we went from this W star to W bar. So wage rate has gone up, employment has gone up, and we've also eliminated this whole area of deadweight loss. We still have a little bit here, which could be eliminated if we set the minimum wage correctly. But we've eliminated some of the deadweight loss. Okay, so these are some examples of how we can actually improve welfare when we have market power using the correct government regulations. We showed that if you just willy-nilly impose taxes on government, on monopoly, you may not improve welfare. So we have to be sort of clever and appropriate with our government regulations to overcome market power. So in the next video, we're going to leave the world of market power and land in a sort of more general environment. We're going to introduce game theory, which is going to set us up for thinking about more complex types of economic environments, which I'm really looking forward to. And I will see you there.